Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
I'm your host, Wayne Zool, and this is the Astro Guy podcast. If you've been following the news, there's quite a lot of astronomy and space discoveries that's going on right now. In early October, it was announced that 20 new moons have been discovered orbiting Saturn. This brings the total of Saturn's moons to 82, which pushes it past Jupiter for having the most moons in our solar system. Jupiter is lagging behind at 79 moons. Several of these new moons are pretty far away from Saturn. In fact, 2 of them take nearly 2 years to complete an orbit around the ring planet, while the other 18 take more than 3 years to make a single orbit. Even stranger, 17 of the 20 moons orbit backwards, or retrograde, around the planet. It is thought that many of these moons were part of a larger moon that broke up some time ago. The James Webb Space Telescope, or JWST, keeps sending back amazing images. Recently, it imaged the Pillars of Creation in M16, and the detail is simply stunning. Artemis 1, unfortunately, is still on the ground. It now looks as though the next launch window is November 14th. Hopefully, it will make it up this time. The moon is full on November 8th, and there will be a total lunar eclipse that morning. This total lunar eclipse will be the last one for more than 2 years. If you miss it, you'll have to wait until March 14th, 2025 to catch another one. The best places to observe the eclipse are the northwestern third of the continental United States, about 2/3 of Canada, as well as parts of northeastern Asia. However, even people on the east coast of the U.S. will be able to catch most of totality. The times that I'll be giving are all for the east coast of the U.S. A total lunar eclipse occurs when the Earth is directly between the Moon and the Sun. The eclipse is the Earth's shadow falling on the Moon. The Earth's shadow has 2 parts, the umbra, which is the dark cone that trails the Earth, and the penumbra, which is the fainter outer edge of the shadow. Lunar eclipses are perfectly safe to look at. You can view the eclipse with just your eyes, but binoculars or a telescope at low power will help you notice subtle changes on the lunar surface. First contact with the penumbra occurs on the morning of the 8th at 3:02 a.m. Likely you won't notice much of a change, as the penumbral shadow usually doesn't make much difference in the brightness of the moon as seen to the naked eye. At 4:09 a.m., the edge of the dark umbra will kiss the moon. It will take a couple of minutes before you'll notice the shadow appearing on the edge of the moon. The color of the umbral shadow varies, and depending on the amount of smoke and dust in the atmosphere, the moon can appear anywhere from a pale, yellowish orange to almost a dark blood red. There was a lunar eclipse not long after the eruption of Mount Pinatubo in the 1990s that many observers reported the moon appearing almost black because of the dust in the atmosphere. When the moon is fully within the umbra, we're at the total stage of the eclipse. This occurs at 5:16 a.m. and 39 seconds. The further east you are, you'll want to make sure that you have a good western horizon, as the moon will be getting low in the sky. Totality lasts for an hour and 25 minutes, with mid-eclipse occurring at 5:59 a.m. You'll need to be in the western part of the U.S. to see all of the total portion of this eclipse. The total portion of the eclipse ends after the moon has set for much of the country at 6:41 a.m. The partial umbral phase ends at 7:49 a.m., while the penumbral eclipse ends at 8:56 a.m. Viewers in the western part of the U.S. will be able to observe the entire eclipse. There will be live feeds of the eclipse available, so if it's cloudy where you are, or you want to stay and watch from your warm bed, you'll have several options, some of which will be listed in the show notes. The annual Leonid meteor shower is predicted to peak on the 19th of November. This year, astronomers are predicting a zenithal hourly rate of up to 300 meteors for this shower. The best viewing should occur between 11 p.m. and moonrise on the 18th and the 19th. At moonrise on the 19th, the shower's radiant will be about 30 degrees above the eastern horizon, so you'll want to look about 30 degrees above that and scan the skies. Leonids tend to be short, swift meteors, and if you're in a dark enough location, you may be in for a treat. Remember, dress warmly and give yourself plenty of time for your eyes to adapt to the dark. Moving on to the planets, Mercury spends the month lost in the glare of the sun and will return to the evening skies in the first week of December. Venus, like Mercury, is lost in the glow of the sun all month and will reemerge in the evening skies just before Christmas. Mars is getting in on the action later in the evening as it approaches opposition next month. Speaking of Mars, the next episode of this podcast will be a very special episode featuring a special guest to talk about the upcoming occultation of Mars by the Moon on December 7th and 8th. Make sure to stay tuned for that episode. It'll be available in just a few days. This month is a great time to observe Mars, as it's nearing opposition on December 8th. At the start of November, Mars rises at 8:19 p.m., while at the end of the month, Mars rises just before 5 p.m. It's easy to spot with the naked eye as the brightest red star in the sky. It's shining at magnitude minus 1.3, so only Sirius and Jupiter outshine it in the night sky this month. As the month goes on, it is very well placed in the evening skies in the constellation Taurus. It also appears larger as the days pass, beginning the month at about 15 arcseconds in diameter and ending the month at about 17 arcseconds. Mars doesn't look huge in most telescopes, but with patience and practice, you can usually spot details on the planet's surface. Look for dark and light patches on the surface. Keen observers should be able to spot the polar caps, although in recent images they have not been showing up very well. Either way, you want to get out and look at Mars, as this will be the best opposition for several years. On November 11th, the 17-day-old moon will be about 4 degrees west-northwest of Mars, making for a nice pair in binoculars. As darkness falls on November 1st, Jupiter will be shining brightly at magnitude minus 2.3, and it will be about 30 degrees above the southeastern horizon. Jupiter reaches its highest point in the sky about 47 degrees above the southern horizon just after 10 p.m. on the 1st, and it sets just after 4 a.m. However, by the end of November, Jupiter will be at its highest around 7 p.m. and will set just after 1 a.m. So Jupiter is clearly dominating the evening skies this month. On November 4th, the waxing gibbous moon will be just over 3 degrees from Jupiter. This will be a wonderful sight to see. Jupiter, which spends the entire month in the constellation Pisces, is stunning in a telescope. The planet appears to shrink from about 47 arcseconds at the start of the month to around 43 arcseconds by month's end. However, at that size, it's easy to spot several dark bands and the red spot when it's facing us, as well as the 4 Galilean moons as they dance around Jupiter. On the evening of the 2nd, try to spot Europa and then Ganymede, as they transit across Jupiter's disk. Europa will clear the planet around 7:14 p.m. and Ganymede about 15 minutes later. See if you can see the moons and their shadows. Saturn begins the month at its highest in the south-southeast and will reach to just about 28 degrees above the horizon. On the 1st, the moon will appear about 5 degrees below Saturn. Saturn's disk spans about 17 arc seconds, while with the rings, the system spans about 39 seconds of arc. Saturn appears as a pale yellow-white star, glowing at magnitude 0.7. You can spot its rings with binoculars, but you'll need a telescope to see them with any detail. See if you can spot the dark lane known as Cassini's division in the rings. At the start of the month, Saturn will be in the sky until nearly 1 a.m., but by the end of the month, Saturn will be nearly due south as darkness falls and set before 10 p.m. So get your glimpses of Saturn in while it's still an easy evening object. Uranus reaches opposition on November 9th. On this day, Uranus is opposite the Sun from Earth, meaning that it rises when the Sun sets and will set when the Sun rises. At this time, we are at our closest point to Uranus for the year and will appear at its brightest. Uranus is just within reach of naked eye visibility, but unlike Venus, Mars, Jupiter, and Saturn, it's not easy to spot, as it's on the edge of just being visible from a dark location. It is currently glowing at magnitude 5.7. Using binoculars will make finding the planet easier, while observing it with a telescope will reveal a small disk. To best see it, use low power to find it. It will look like a bluish-green bloated star. Then, boost the magnification to at least 100x to reveal the disk of the planet. Uranus spends the entire month in the constellation Aries. Neptune is in Aquarius all month and is located just over 6 degrees west of Jupiter. The planet only spans a little more than 2 arc seconds and glows faintly at magnitude 7.7. You'll need binoculars to spot it, but to make out any sign of a disk, you'll need a telescope at high magnification. So that's it for the solar system this month. Now we're going to venture out a bit to explore some of the best objects that are in the constellation Perseus, the hero. This northern circumpolar constellation has lots of interesting stars and objects for you to enjoy. Let's start with the brightest star in Perseus and see what it has to offer. Myrrhfac, or Alpha Persei, is a white double supergiant star. The main component star shines at magnitude 1.79, while its companion is 10 magnitudes fainter. That means that its companion is 10,000 times fainter than the main component star. That makes it difficult to spot. The pair are separated by almost 3 arc minutes, so it is possible to glimpse the companion with at least an 8-inch telescope under excellent seeing conditions. Myrrhfac is located about 510 light-years away from us. More famous than Myrrhfac, but not as bright, is the star Algol, or Beta Persei. It is often referred to as the Demon Star. This eclipsing binary star system is made up of 3 stars, Beta Persei AA1, AA2, and AB. The primary star, AA1, has 2 other stars orbiting it. Larger and fainter AA2 passes in front of AA1 from our perspective every 2.86 days, causing the star to dip from magnitude 2.1 to magnitude 3.4. The eclipse lasts for about 10 hours. The third star also eclipses the primary, but the dimming is extremely minor and only detectable with photometric equipment. Once you learn where Algol is, You can find charts on the web that let you know when it will be at minima or eclipsed. Compare how it looks when it's not eclipsed to when it is. It's a very noticeable difference. Algol is located about 90 light years away from us. The most famous and easiest deep sky object to spot in Perseus is the beautiful double cluster. Technically, it's two separate open clusters, NGC 869 and NGC 884. The pair appear very close, only about 15 arc minutes apart. They are also both similar in brightness at magnitudes 3.7 and 3.8 respectively. Each open cluster spans nearly the size of the full moon, so this is easy to spot with binoculars, while a telescope at low power will reveal many dozen stars that resemble diamonds scattered on black velvet. If you're in a dark enough location, the double cluster can be spotted with the naked eye as an elongated patch of light. NGC 869, the westernmost of the pair, shines at magnitude 3.7 and spans around 20 arc minutes and is located about 7,500 light years away. The cluster is 33 light years wide and approximately 14 million years old. NGC 884 spans 30 arc minutes and is slightly dimmer at magnitude 3.8. While both clusters are very similar in age, NGC 884 lies a bit further away, at a distance of 7,600 light years. To locate the double cluster, start at Mirfac and sweep towards Navi, the middle star in the W of Cassiopeia. About halfway along that line, you'll find the double cluster, easy to spot and enjoy. While observing it, you should note that there is a chain of stars that leads north of the cluster that you can follow for about 2 degrees. Doing so will bring you to the large open cluster Stock 2 in neighboring Cassiopeia. But for this episode, we're sticking with Perseus, so we'll move on to our next object. Messier 34, sometimes called the spiral cluster, is a nice open cluster that's often overlooked by its nearby proximity to the double cluster. M34 glows with a combined light of magnitude 5.5. Several years ago, I was able to just spot this with the naked eye from a very dark sky location. However, it's easy to spot with binoculars, and a telescope will reveal the cluster nicely. M34, or NGC 1039, is comprised of about 400 stars that spans 35 arc minutes across. The cluster is about 1,500 light years away, and its member stars are between 200 and 250 million years old. In binoculars, the cluster will appear as a mottled glow, while in a telescope, you'll be able to resolve dozens of stars. To locate M34, start at Algol and sweep 5 degrees west and then 2 degrees north, and you should easily spot the cluster. Another of Messier's objects are within the borders of Perseus. The second and last M object there is M76, also known as NGCs 650 and 651. The double entry in the NGC catalog is a mistake, as it was once thought to be 2 separate objects, but we've since learned that it is in fact just one object. It is commonly called the Little Dumbbell Nebula, as it appears similar to the planetary nebula M27, the Dumbbell, in Vulpecula. Many people see a resemblance to their structure, although M76 is smaller and fainter than its larger namesake. Glowing faintly at magnitude 10.1, the nebula spans 2.7 by 1.8 arc minutes, and is best seen in a 6-inch or larger telescope. The nebula was created when its central star puffed off its outer layers of gas, creating the nebula that we see today. To locate M76, start at Mirfac and sweep just over 16 degrees east, and you'll come across a pair of stars, magnitudes 3.5 and 4, that are separated by about 2 degrees. From the fainter of those two stars, sweep about 1 degree north, and you should spot M76. Make sure to look at it with different magnifications to try to spot some of the details within the nebula. Our last object that we'll explore in Perseus can be a real challenge. I have only been able to observe it visually a couple of times. To visually spot the California Nebula, or NGC 1499, you'll need a wide-field telescope, very dark skies, and a nebula filter that will pass hydrogen alpha light. That will help a lot. This nebula is large, spanning about 2.5 degrees in length. In photographs, it does resemble the state of California, hence its name. While it is large, it glows at only magnitude 6, so it's a challenge to spot it visually. However, it's easily imaged with a camera using exposures as short as only 5 seconds. Classified as an emission nebula, this cloud of gas lies about 1,000 light-years away from us. To locate the California Nebula, start at Mirfac and sweep halfway to the Pleiades, and then sweep east 4 degrees, and with some luck, you should just be able to make out the faint nebula. Can you spot it? It really can be very challenging visually, but seeing it is definitely worth the effort. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com, or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform, as this can help us get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.